Okay, first week of videos. We're going to quickly review coordinate graph. You all have been working with graphing things since probably 5th, 6th grade. Here's an example of a coordinate graph, an XY. This semester we're going to be doing a lot of graphing, and you're going to be using Desmos much of the time, but anytime you have an equation, so let's see, f of x is equal to, or y is equal to, when they give you a bunch of stuff, one of the quickest ways to understand what is going on is to graph it. And if you're ever stuck, create a table of values and then just pick 5 values. So my go-to values typically are, so here's your x, here's your y, -2, -1, 0, 1, 2, to keep it really, really easy. But if the graph has been shifted, so let's say you have something like this. Well, remember, inside parentheses tells you whether it's shifted left or right, and it's always the opposite. So if we know that +4, when x is equal to +4, zeroes out that graph that it's going to be shifted, you might want to have, instead of 0 in the middle for your x value, you might want to have 4 in the middle, and then this would be 3 and 2, and this might be 5 and 6, to give you an idea of what's happening to the graph as it's shifted over to 4 on the x-axis. Okay, then, so that's the table method. Then remember, if you've got an equation and you have it in slope-intercept form, b is where it touches the y-axis, and m is the slope, how far you go up and how far you go over. So if you have y is equal to 3x minus 5, you're going to start down here at -5, because that's the b value, and this tells us our slope up 3 over 1. So up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. Then you have enough points to go ahead and connect those points and draw a straight line. And then also, if you're given a whole bunch of coordinates, just plot the points, and depending on the situation, you might draw a line, you might not draw a line, but whenever you have coordinate values, you can go ahead and graph those. Key parts of a graph, well, you've got the x-axis. Remember, the x-axis, what the x's are doing is called the domain. The y-axis is the axis that is the vertical axis, and the y values, what the y values are doing, that's called the range. Then we've got the quadrants, always written in Roman numerals. So in the first quadrant, both the x and the y values are positive. In the second quadrant, the x values are negative. Well, that makes sense because we're to the left of 0. And the y values are positive because we're above the x-axis. In quadrant 3, both x's and y's are negative. That makes sense. We're to the left of the y-axis and we're below the x-axis. So down here, negative, negative. And finally, the fourth quadrant, the x values are positive, the y values are negative. All right, let's keep moving on. The equation of a vertical line, as soon as we're talking about lines, x is equal to a concept. So if we had x is equal to -2, what that would simply mean is, on the x-axis, there'd be a vertical line. So when x is equal to any constant, a number by itself is a constant, that's where you draw a vertical line. For a horizontal line, it's when y is equal to any constant. So if you have y is equal to 3, 1, 2, 3, that means all of the y's are equal to 3. All right? Everything slope. What is slope? Well, slope is the rate of change. How fast or slow something is changing. Notation for slope, well, in probably 6th, 7th, 8th grade, you learned m is equal to rise over run. Another way to write that is the change in y's over the change in x's. And remember, that makes sense. Remember, the slope formula is y2 minus y1 over x2 minus x1. Well, look at this is the change in y's. That little, what looks like a triangle is called a delta. The change in y's over the change in x's. So this is slope notation. This is slope notation. All right. So when you go to find slope, you could look at a graph, and if you have a drawing, you might use rise over run. If you have 2 coordinate points, you'll use the slope formula. And if you have a line or an equation, the slope is that value attached to the x. Remember, the slope doesn't include the x. It's whatever's attached to the x that is the slope. For parallel slopes, parallel lines, right? Well, their slopes are going to be the same. So if you have y is equal to 2x plus 5, y is equal to 2x minus 2, see how those slopes are the same? Those are going to be parallel lines. And parallel lines means that they will never intersect. And then for perpendicular slopes, the slopes will be opposite reciprocal. So opposite meaning if this is positive, the new slope will be negative, and the new slope will be the reciprocal of the former slope. So for example, if you had y is equal to 2x plus 5, a perpendicular slope would be y is equal to negative 1/2. Notice 2 is positive, 1/2 is negative, and 1/2 is the reciprocal of 2. So let's say these two lines, if you were to graph these two lines, they would be perpendicular to each other. All right, let's keep going. Functions. How do you know if something is a function? Because once you get past pre-algebra, algebra and beyond, we often talk about functions, right? And certainly in college algebra class or an advanced algebra class, we'll be talking about functions. And this is how one way to know if something is a function or not. It's called the vertical line test. If you take a vertical line and as you go through the function, if it only touches the graph at one location, it passes the vertical line test, then it is a function. Notice if we were to take this vertical line everywhere through this function, it would pass. All right. Linear equations and their forms. Standard form, ax plus by is equal to c. So let's say 2x plus 3y is equal to 12. That's standard form, often used in word problems. Slope-intercept form, y is equal to mx plus b. B is where it touches the y-axis, and you always plot that point first. And slope is the rise over run, how fast things are going to be changing. And once you plot the b value where it touches the y-axis, so if you have y is equal to 2x plus 5, you'd plot the point where it touches the 5. The slope is 2, or that invisible 2 over 1. So up 2 over 1. And then point slope form. If you're given coordinate points and you're given the slope, or if you're given 2 coordinate points, you would find the slope, then with the slope and one of these points right here, you would plug it into the point slope form, and then you'd solve for y, and then you could graph it. All right, that's it for this one.